Okay, so this is reviewing chapter 16, specifically about combination problems. The first problem we come into, we have to think about combinations and do some review on that. So let's take a look at flipping a coin 5 times and getting an H once. So if we think about it, flipping a coin 5 times, we can get heads, and the rest can be tails. However, it could have been tails first and heads second. So what we say with that is 5 factorial. However, we have one thing being moved around. So what we have to do is make our equation okay, 5 factorial divided by 1 factorial times 5 minus 1 factorial, which leads us to 1 factorial times 4 factorial on the bottom, which if we write that out, those 4 will cancel with those, and we just have 5 over 1, which says we have 5 different ways that this can occur, which makes sense because it can either be in the first spot, second spot, third spot, fourth spot, or fifth spot. How we write that in notation, you may have seen this before. It looks like this, where that's like how many different spots you have, right? And R is, well, it's just the one spot. So we would write that as 5C1. What you're going to see in your book and in this class is we're going to actually write this as 5, 1 with parentheses around it. So it looks kind of like a fraction, but there's no bar in the middle. On our calculators, if you go to the Math button and you scroll over to Probability, go down to number 3, it should give you this. Type in 5, 1, and it gives you the answer. So let's try that with flipping a coin 5 times and getting H twice. Well, that's going to be this right here, which we can simply go to Probability, number 3, and say 5, 2, which gives us 10. So if we look at this, that would be 5 times 4 times 3 times 2 times 1. Sorry, that's a 5 factorial. That's going to be a 2 factorial. And that's 5 minus 2 factorial. So that's going to be 5 minus 2, which gives us 3 factorial. So that's 2 times 1 times 3 times 2 times 1. Those will cancel out. 2 divides by 4, and we get simply just 5 times 2 divided by 1, which is just 5 times 2. So this says, flipping a coin 5 times, getting an H only once. There's 5 different ways to do that. Flipping a coin 5 times and getting an H twice, there's 10 different ways we can write that. Well, let's move this into what we're doing in this class, in this chapter, is probability of these kind of events happening. So the first question we're going to look at is rolling a die 5 times and getting a 6 twice. So it's similar as this kind of problem, except now we're talking about the probability of that happening. So let's first think about probability of getting a 6. Okay. Since a die, we're going to use a standard die which has 6 sides. You have a 1 out of 6 chance of that happening. The probability of it not being a 6 is the other remaining numbers, so you have 5 out of 6 numbers. So how this works is we're going to say, well, we have 5 times we're doing this, so 5, getting it twice. So this is our 5C2. And now we have a 1 out of 6 and a 5 out of 6 probabilities. Now, since it's happening twice, I have to do this to the second power. And since this is going to be happening 3 times, because if there's 2 that are the successes, the things that we want, there's 3 of the things that are not successes, the things that we don't want. So one more time. We have 2 things that we want, the 6s, 3 things we don't want, which are not 6s, and the reason why we're doing a combination is because we can roll a 6 first, we can roll a 6 second, third, fourth, fifth. It doesn't matter as long as it happens twice. Just like with the flipping a coin, we don't care where it happens, we just want to know how many times can it occur. That's where this comes in, the 5-2. 5 combination 2. So I'm going to go ahead and do math, probability, 5 combination 2, and then right next to it, I'm not going to hit enter, I'm going to go ahead and move to the right. I'm going to push 1 divided by 6, and there's 2 of those events. 5 divided by 6, we know there's 3 of those events. We're going to hit enter, and it says it has a probability of happening 0.16075. We're just going to write this as let's go 5 digits out. So as a percentage, this would be about so rolling a die 5 times, it kind of makes sense that rolling a die 5 times, you have a small chance of getting a 6 twice. It's not impossible, but it's a small chance. So now it comes a little tricky here where we have a 5, rolling a die 5 times, but this time getting a 6 at least twice. So that means getting a 6 2 times, 3 times, 4 times, 5 times. So let's see that probability. So we know right now getting a 6 twice is going to look like this. We have to add that to the probability of getting a 6 3 times because it says at least. This here says I got this 3 times and this 2 times. And I ordered those 3 in any combination. This here says in any 4 combination I got a 1 out of 6. I'm sorry, a 1 6, right? That was my 6. There's 4 different spots that can fill. This 5 out of 6, the not 6, it has 1 spot it can fill. And I'm going to go ahead and finish that off by saying, well, a little redundant. But what if you get the 6 all 5 times? And the not 6 0 times. So we can do this in our calculator. And I'm going to show you after we do this the long way. We can actually do it a fast way as well. So there was a 5 combination 2 of the 1 out of 6 2 times, 5 out of 6 3 times. Add that to 5 combination 3 3 times, only 2 times. Whoops. 5 combination 4, because we got the 6 possibly 4 times. The not 6 1 time. Five combination 5 we got the 6 this time, all 5 times, and the not 6 0 times. Okay, so that was the long way, and I get this number. Okay, which is about 20%. So it makes sense that to roll a die 5 times and get in a 6 perfectly 2 times is 16%. You have a little bit higher chance, because what if you got a 6 3 times, 4 times, 5 times? It's a little bit higher. Now in the calculator, that took a long, not a long time, but there's a faster way. So that now is going to be under your distribution, which is above the variables. Going to push the blue button, second, in distribution, and go all the way down until you see something about a binomial. Binomial PDF, binomial CDF. We're going to use the one with C for combination. On the left here it says B. Now, it gets a little bit tricky with this, but the way I see it, the way I remember it, the trials is your top button here. The top button, the top number, 5. So we have 5. Now for the p-value, usually that means the successes, but for the calculator, the way we work it is what is the exponent that's going down after each trial. The exponent that's going down each trial is the 3, 2, 1, 0. That's the 5 over 6. And what is the starting exponent? 3, 2, 1, 0. So 3. When we do this, so 5 trials, starting with 5/6, the value is 3. Okay. Push enter. And we get the same exact result, 0.1962. 0.196244. As you see, it's the exact same number. So there's no reason to have to type this in because you might make a mistake. But just remember, 5 is how many trials? So there's 5, right? There's 5 different times you're rolling the die. The 5 over 6 came from the event that had the exponent that was going down, that was descending. And the 3 is the starting exponent. Okay, so let's try it again. This time the probability of rolling a die 5 times and getting a 6 at most twice. So that means you get it 0, 1, or 2 times. So let's write it out. Okay, let's start with what we know. We can get it twice, and it would be, you would get the 6 twice and the not 6 3 times. We're going to add that to, what if you only got a 6 once? And a not 6 4 times. We're going to add that to getting a 6 no times and getting a not 6 all 5 times. So once again, at most twice. That means 0, 1, or 2. So we start with 2 since we know that one, and that one's going to count down. 2, 1, 0. So when I go to distribution, now this time I'm going to show you another shortcut. If we push up, we go to the bottom of the list. That's a little bit faster. So the one that's got the CDF. Okay, there's 5 trials. Which one counts down? Well, the 1 over 6 is the exponent that has the exponent that counts down. So 1 over 6. And the value it starts at is only 2. So once again, the exponent that goes down is the one that has the 2, 2, 1, 0, the 1 over 6. The exponent it starts at is 2. We're going to paste that. And I get this number here. Okay, so this is about about 96%, which makes sense. Rolling a die 5 times, it's not necessarily a high probability of getting a number once. I mean, you might, but getting it at most twice, it says here about 96% of the time. You roll a die 5 times. At most, you'll get a 6 twice.